Hello, welcome to another problem session. This problem from this website, um, and there are many more problems there and more discussion. Okay, so this kind of problem goes under the heading of what we call coupled systems. What we mean is there are two or more objects who are moving together. Is two or more objects whose motion is somehow related. And this is a very common problem and confuses a lot of people. So some of the analysis will be for the whole and then for the individual parts. So you'll have like two kinds of analysis, whole and each part or just one other part. Okay, and then these two together, you have to think together. Think broadly and more comprehensively. Okay, so let's look at this problem. Here we have one book here, and we have another book here. I'm going to push on it. This is on a table surface. When I push on it, together, this whole thing together moves with one value of acceleration. So this coupling here, coupling of motion, has made acceleration of 1 equals acceleration of 2. So here is the constraint. We call it constraint, is constraint of coupling of the motion has caused that acceleration of 1 equals to acceleration of 2. Also, direction of acceleration of 1 same as direction of acceleration of 2. Sometimes it may be the magnitude is same and the directions are different. So there will be problems like that. But here, everything is same. So first question says, what is the magnitude acceleration of the two blocks? Well, if I think of them as one, and I look at all the forces, so think of, so for A is the whole analysis, and I look at the whole thing. So there's a force F, and this is on a frictionless table. So there is no friction here, so no other force there. Then we have a weight, m1 plus m2g, and you have a normal force. That's all there are in terms of forces. Okay, and a result of this, the acceleration is that way. Just call, because there's only one value of acceleration, just call it A. Okay, so it's very easy to see that there is on this x-axis and this is the y-axis. Then these guys are just vertical, so everything along in this direction. So the x motion looks like F equals m1 plus m2 times A. And so the A is just F over m1 plus m2. So that's A. And this, of course, this is equal to A1 equals to A2 for the two books. Okay. The trouble comes when we do things like this. What is the magnitude and direction of the force on book 1 by book 2? That means I need to look at what's happening to book 1, right? So B, just look at the book 1. We look at the forces here. So of course we have F this way, and we have its M1G, its Fn1, and its acceleration 1, which is same as acceleration A over there. We found. So let's call it we found 1 as we found in 1. If you think this all the forces, then actually this will be a problem, because if you say all these forces, then say this, let me wrongly thinking, say this all there is, then you will say this F should be M1 times A. But we already found F is M1 plus M2 times A. So this would be totally wrong. So there is a force from book 1, force by book 2, I mean by 2 on 1. So you can think of that as like as the first book is trying to move, second book is in the way, so there's a normal force between them. So this is actually a type of normal force. Normal force, vertical to the surface of contact of the two books. So now that we set, and this is the force we want to find, so now we set from this to X and Y again, and Y direction we don't need to know. So in the X direction you have F minus, let's call this F2, let's call this guy F2 for simplicity, equals to M1 times A, which is A is over here, so we can just write down M1 F over M1 plus M2. Okay, so I need to do F2, so F2 will be, I bring this F2 on this side and this guy on the other side, so F minus M1 F over M1 plus M2, and so if you simplify it, it's going to be M2 F over M1 plus M2. So this is the B. Of course, another way we could have found, another way we found this force is by as follows. We look at book 2 and use Newton's third law to say force on book 1 by book 2 is opposite of force on book 2 by book 1. So this would be like looking at this diagram, book 2. So book 2 there's no F on book 2. So instead of F, this is force on 2 by 1, which is same as F2 in question. In terms of magnitude, is that this direction is this way and the other direction is that way. Okay, they're just opposite directions, but the same magnitude force. And weight and normal, M2G and F normal force, they are vertical, and these are along the horizontal. As a result of this thing going with acceleration A1, which is same as A. So if I apply on this guy, This is only this force. Exactly, this F2 is going to be some this M2. F2 will be M2A2, and put over there M2F over M1 plus M2. So this is another way to get the force between 1 and 2. Here it uses Newton's third law to kind of get the force on 1 by 2 by working out force on 2 by 1. Okay, I think this is a good problem. I will do another problem like this, which is you stacked up the books and push on one of the books in another video. Okay, see you in another video. Bye.